All right, here in this video, we are going to take a look at graphing linear inequalities. So a line, but it's not just an equation, it has that greater than or less than component. We'll just start with one individually, and then we'll build the systems, which will have two working together. So I'm just going to remind you, y is greater than, this is greater than, negative 3x minus 1. Now this is already in y equals mx plus b. So that's a good start. That means I can go ahead and graph. So I'm going to start here at negative 1. Now I have negative 3. Remember that has to be over 1. So negative 3 over 1. So drop 3. 1, 2, 3 over 1. I'm going to go again. Drop 3. 1, 2, 3 over 1. And then I need to put my line. Now this is where inequalities change a little bit. So do remember that if I have a greater than or a less than, these are open circles where a greater than or equal to or a less than or equal to is closed. So these are open, these are closed. Well, on a line, what does that look like? Well, open is dashed and closed is solid. So this is an open, so let me get a dashed line set up. Okay, so there's my dashed line because this is greater than, it's not equal to, it's just greater than. But I also need to shade. I have to say, well, all of my solutions are over here and it's greater than, so it's above. So I would say, okay, from my y-intercept, it has to be everything above. So that means that it would be everything over here would be my solution set. So this is where we were practicing shading. So any of these places would absolutely work. If you wanted to use this coordinate, that works. This coordinate here works. These are all solutions to our inequality. Now, number 19. When I look at this, the first thing I notice is we're in standard form. So I'm going to go ahead and I'm going to move everything over. So I'm going to start with the 5x. So we'll have 3y this would be less than or equal to negative 5x plus 6, divide by 3 all the way across. And so y is going to be less than or equal to negative 5/3 x plus 2. So we're going to start at 2, and then we're going to use our slope, negative 5/3. So 1, 2, 3, 4, 5. 1, 2, 3. We'll get a couple on here. And then we'll want to draw a line here, but this is actually equal to, so this will be a solid line. So let's get that drawn. Okay, so now what we're going to want to do is go ahead and think about which side I would need to shade that on. So less than, so if I was here on my y-intercept, less than would be below. So that means that everything on this side, let's see here, everything on the below side. All right, so yeah, everything below your line would be shaded for this one. All right, let's take a look at a couple more. Number 20, the first thing I notice on number 20 is that I'm still in standard form. So I'm gonna go ahead and move the x over. No problem there. So I now have negative 2y is less than or equal to negative x plus 8. We're going to go ahead and divide by a negative 2. Now I'm going to pause. I'm dividing as by a negative as a mathematician. So I'm going to circle this to remind myself that I'm going to need to flip that or reverse my sign because I'm dividing by a negative. So this is going to become y is greater than or equal to, now remember there's a 1 here, so that's 1/2 x. And 8 divided by negative 2 is negative 4. So if we start at negative 4, 1, 2, 3, 4, I'm on the y-axis for my b. And then I'm going to follow my slope, up 1 over 2. And we can use that to go ahead and create our line. Now, again, greater than or equal to, that means that I'm going to have a solid line. And now we have to think, okay, which way am I going to shade? Now it's a greater than, so it would be above the line. So from the y-intercept, above would be on this side of the line. So I'd say, well, that means that we would really need to shade everything above that line Just going to draw some lines here. But I want to remind you, everything above the line, all the way to the line, and actually including the line, because the line is solid today. All right, 21. Y is greater than 1. Y is greater than 1. Well, I noticed right off, there's no x. So this is one of our special cases with no x. We talked about this using the word hoy just to help us. There's that y, there's the y, horizontal, a slope of 0, and it's y equals. So y is greater than or equal to 1. I'm going to go where there's 1 on my y-intercept, and it's horizontal. I also know it's dashed because it's not greater than and equal to, it's just greater than. So I'm going to put my dashed line. And greater than would be above. So that means everything up here would be shaded. Everything above the line would be shaded in. All right, so that's a quick review of single inequalities, but we also need to look at doubles, meaning we need to graph them on the same line, and then we can find where they intersect, where they overlap is what we're looking for. So a system, remember they're working together, and we're really looking for the overlap. So in 22, I have x plus y is less than -1, and then I have x minus y is greater than 8. Well, first up, I noticed that they're both in standard form, so I'm going to need to go ahead and get those moved over. In the first one, I'm going to move the x over, so y is less than -x minus 1. And the second one's just a little different in that it has this negative in front of the y. So when I move the y over, or the x over, I still have a negative y here is greater than -x minus or plus 8. But now we're going to divide by a negative, which means I need to reverse my symbol here, my inequality. So y is actually going to be less than, negative divided by negative makes a positive, and then it would be subtract 8. So let's go ahead and graph these out. I'll start with the top one. I know that I start at -1. I need to follow a slope of down 1 over 1, down 1 over 1. So we can put quite a few of these little dots on here, so it can help guide my drawing. Go back and look. Are we solid or are we dashed? Yep, we are going to be dashed, so I'm just going to go ahead and just maybe make these a little bit more pronounced at this point. So this is just dashed. And I'm going to think to myself, less than, which means that it's everything below it, right? Okay, so I'm just going to kind of put a couple of lines on so I know it's everything below. I'm not going to shade because I really want to know where the system overlaps for my solution. So now let's switch over to the other one. Less than here, but x -8. So let's go -8. 1, 2, 3, 4, 5, 6, 7, 8. Well, let's count that again. 1, 2, 3, 4, 5, 6, 7, 8. Here's 8. Now I'm going to go up 1 over 1, up 1 over 1, up 1 over 1. And as I'm doing this, I'm wondering, is this going to be a dashed line as well? It is. So I'm just going to go ahead and start dashing that line. Okay. And it is less than. So this is everything below the orange line. So where do they overlap? Where do I have both purple and orange? Well, in this section down here. So this here would be my solution set. This section down here is my solution when you overlap. It's where they both are crisscrossing. So it's this little triangle. All right, let's take a look at 23. Top one here, not in slope-intercept form. We're going to have to change that over. I'm going to start by adding the y to the other side. So less than or equal to x plus 21. Divide everyone by 3. So y is less than or equal to 1/3 x. Y 1/3, there's that 1 in front of that x, plus 7. Now I'm in slope-intercept form, so I can graph that. Let's go and do that. 7. 1, 2, 3, 4, 5, 6, 7. Follow my slope, up 1 over 3. Go ahead and look, am I going to have a solid or am I going to be dashed? And in this case, it's equal to, so it will most likely need to be solid, right? So let's go and get a solid line on here. All right, I've got the solid line. Now I'm shading above or below. It's y is less than, So I would definitely be shading below. Just going to give myself a couple here, just so I know it's everything down here. And then I'm going to go ahead and work on my second line. Well, it's already in slope-intercept form, so let's do that. 1, 2, 3, 4 is the y-intercept. And the slope looks like -1 over 1, -1 over 1. And let's take a look. Is this going to be solid 2, or should this one be dashed? It is also greater than or equal to, so I'm going to go ahead and get my solid line on here. Okay, now that I have my line, greater than means that the orange would be everything above the orange line, and I'm looking for the section where they overlap, and they overlap here in this triangle, so I would say that my solution set would be here. And so sometimes I'll just highlight this one section. I'm just going to mark it so that you know that this is our solution set. And the other lines just kind of show each line individually. All right, 24. I notice right off that those are, again, both in WOM standard form, and we're going to need to change both of them. So pause, change them, but before you graph them, come back, make sure we have them set up right so that we're shading the right directions. All right, so our top equation is going to be y is greater than or equal to -4x plus 4, and then the bottom will be y is greater than 3/2 x minus 7. So go ahead, pause, graph those out, make sure you marked your solutions where they overlap. All right, so our solution set will be all of the possibilities up here in this top triangle here, up here on the right. Okay, let's just take a look one more. I have 4x minus 5y is greater than -35. So let's go and move the 4x over. So -5y is greater than -4x minus 35. Going to go ahead and divide everyone by -5. Remembering I divided by a negative, therefore I am going to reverse that inequality symbol. So y is less than 4/5 x plus 7. And then my bottom equation, I really don't need to do much with. It's already in format. Let's just go ahead and put this first one here. So let's go 7 up on the y-axis. 1, 2, 3, 4, 5, 6, 7. And I need to get my coordinate. Oh, well, that doesn't go to 4/5, but that's okay. We can go the other way. We're going to drop down 4. 1, 2, 3, 4. But because I'm going opposite, I got to go opposite backwards too. So 1, 2, 3, 4, 5 here. I'm going to go again. 1, 2, 3, 4. 1, 2, 3, 4, 5. All right, and now I'm looking, this is going to be a dashed line because it is not equal to, it's just going right up to it, but it's not actually including it. Less than would be everything below it. Okay, now let's take a look at the second equation. This inequality says x is less than or equal to -3. There's only an x. So remember we kind of talked about an easier way to think about that is VUX. Because I only have an x, that means I have a vertical line. So I'm going to go where x is -3. 1, 2, 3. And I need to draw a line, and it's going to be solid, and it's going to be straight up and down, or as straight up and down as I can get on this board here. So this is my vertical solid. And it is also less than, which means that it's everything to the left, because what's less than -3? Well, -4, -5, -6, right? So less than would be going this way. Therefore, my solution set, which of these little areas is it overlapping? Well, it's overlapping down here on the left, on the bottom. So I'm going to say, well, this is my solution set. Everything in this section created by the two lines. So everything between the lines all the way through here is my solution set. So important reminders for inequalities. You have to think, do I need a dashed line? Do I need a solid line? And then when you are setting those up into y equals mx plus b, do remember that if you as a mathematician divide by a negative all the way across, you need to reverse your symbol. What else? Systems have a set of solutions. So instead of saying, well, it's just this one place, it's everybody inside that one section. So you'll have where they cross, it'll be one of the 4 sections will be your entire solution set.